Welcome to another episode of Terry's Notes. Today we're going to be looking at the May 2016 paper, question 9. So the first part of the question had to do with functions. We have two functions, f and g. So f of x is equal to 2x minus 7, and g of x is equal to x squared plus 1. Right? So the first thing the question asks us to do is to find f inverse, right, which is this. So what we need to do is basically f of x is equal to 2x minus 7. Now the procedure for finding the inverse of a function is to first let y equal to 2x minus 7. Your next step is to interchange x and y, right? So anywhere you see y, you put x, and anywhere you see x, you put y. So this will become x is equal to 2y minus 7. So we can write this as 2y minus 7 is equal to x. So therefore 2y is equal to x plus 7. So y is equal to x plus 7 over 2. So therefore f inverse of x is equal to x plus 7 over 2. So the answer for the first part is x plus 7 over 2. The next part is to find the inverse of g. Okay, so let's see this. Right, so we know that g of x is equal to x squared plus 1. So the first thing we have to do is to let y equal to x squared plus 1. Then we interchange x and y. So this will be x is equal to y squared plus 1. So we can write this as y squared plus 1 is equal to x. Y squared is equal to x minus 1. And therefore y is equal to the square root of x minus 1. Alright, so therefore g inverse will be equal to square root of x minus 1. So this will be square root of x minus 1. Next part is a composite function. We want to find fg of x, right? What is fg of x? So basically fg of x is, so fg of x, what we are doing, we are taking the function g of x and plug it into the function f, right? So g of x is x squared plus 1. So therefore fg of x will be 2 by x squared plus 1 minus 7, right? I'm taking this value here, x squared plus 1, and I'm plugging it as x into this function, right? And this will give us 2x squared plus 2 minus 7, which is equal to 2x squared. 2 minus 7 is minus 5. So fg of x is equal to 2x squared minus 5. Okay? And the last part here is fg inverse, right? So basically what they're asking you is what is the inverse of this function here, right? So let me see if I could do it quickly in the corner here. So we know fg of x is equal to 2x squared minus 5, right? So we let y equal to 2x squared minus 5. Then we interchange. So we get x is equal to 2y squared minus 5. And therefore we can write it as 2y squared minus 5 is equal to x. 2y squared is equal to x plus 5. Therefore y squared is equal to x plus 5 over 2. So therefore y is equal to the square root of x plus 5 over 2. Right? So therefore fg of x is actually equal to the square root of x plus 5 over 2. Alright, this probably would have given students some trouble, but as you can see, it's pretty straightforward. Let's do the last part. I said to show that, write this on the next page actually. Fg inverse x. So we have Fg inverse of 5 is equal to G inverse F inverse of 5. G inverse F inverse. So what they're asking us to do is to show that Fg inverse is equal to G inverse F inverse of 5, right? So we already know what this is. We know that Fg there should be no brackets here. We know that Fg inverse of x is equal to x plus 5 over 2. We find the square root of that, right? So therefore Fg inverse of 5 will be equal to, we substitute x equal 5 into that expression. So we get 5 plus 5 over 2, which will be equal to 10 over 2, which is equal to 5. So therefore, on the left hand side, that'll be equal to square root of 5, right? So when I say the left hand side, I mean when I work this out, I'm getting square root of 5. Now we want to find G inverse F inverse of x first, right? So we know what F inverse was. Previously we worked out F inverse and we got this. F inverse of x is equal to x plus 7 over 2. X plus 7 over 2. We also know that G inverse of x is equal to, that was x minus 1 square root. So therefore, if we need to find this expression first, we're going to take F inverse and we're going to plug it into G inverse. So we're taking this and we're going to substitute it as x in this expression here. So that'll be, hold on, let me check something here. Yeah. Right, so F inverse, right, so this will be x plus 7 over 2 minus 1, and we find the square root of that, right? Now to find G inverse F inverse of 5, this will be 5 plus 7 over 2 minus 1, and we find the square root. This will be 7 and 5, 12 over 2 minus 1 square root, which is equal to 6 minus 1, which is equal to square root of 5. So we've just proven this statement here, right? The question is not too hard. It just requires that you be very careful with what you're doing. Okay. Now, the part B to this question had to do with a distance time graph. So this requires some interpretation. So they said the distance time graph shows the 3-stage journey of a car traveling from town A to C. Right? So this is A here, and this is C. And what they said, right? So town A to C and back to town A. Right, so back to town A is represented by this point here. Now they said state the time of day at which a car arrived at town C. remember this is a distance time graph, so all they're asking you to read off this value here. Right? Now you need to understand what the scale on the time axis. This is 6 to 7, right? So that is 1 hour, which is 60 minutes. And we could divide the 60 minutes into 4 parts, right? So like this distance here, from here to here, that represents 60 over 4, which is equal to 15-minute intervals, right? If you want to know the time at which you arrive at town C, I mean, from here, this is 8 and this is 9. This point here is this time is what we need, which is midway between 8 and 9. So that is really 8:30, right? So that's the time at which the car arrived at town C. Now they said calculate the total time in minutes for which the car stopped during the journey. Right. Now make sure you understand what is happening here. In stage 1, the car is actually moving, right? And it moves until it reaches 7 o'clock. This here, notice that the distance has not changed. It reaches a distance of 40 kilometers and nothing happens for a period of half an hour, right? This represents when the car is stationary. This horizontal line here also represents when the car is stationary. So they want the total time in minutes. So in this first part where the car stopped, this is represented by 30 minutes. So this here, from here to here, this piece here, this is 30 minutes. And this short piece here is represented by 15 minutes, right? So we're looking at where the part of the graph, where it is horizontal. So that will give us a total of 45 minutes, right? 30 plus 15. So this answer here is 45 minutes. Okay. Now they said determine the constant speed of the car during stage 2. So stage 2 is represented by from here to here. That is this line here, right? This is stage 2, right? And they want the constant speed during that period. Now to find the speed from a distance time graph, we simply need to find the gradient in stage 2. All right, so speed here would be equal to, we need to find, let me just draw this here. We need to find the slope of this line. So all we need is this distance here, which is represented by 100 minus 40. 100 minus 40 divided by the difference in time. So we want to know what is this distance from here to here. So this is from here to here is, we have 1, 2, 3, 4 15-minute interval. So therefore that is actually 1 hour. So we leave that as 1, right? So therefore this will be 100 minus 40, which is 60 kilometers over 1 hour, which is equal to 60 kilometers per hour, right? So that is the constant speed of the car during stage 2. And the last part now, which is a little tricky. So they said to calculate the average speed of the car for the time during which the car was moving. Okay. Now, the time for which the car was moving would be stage 1, stage 2, and stage 3. And you want to get the average speed of the car for that period, right? Now, okay, so average speed is equal to total distance over total time, right? Now visually, if we think of the car as starting at the point A, so car starts at the point A and it travels to some point C, right? So the car is doing this. The car is traveling here, traveling. It reaches the point C, right? So that is stage 1 and stage 2. So if you look at the graph, right, the distance from A to C is actually 100 meters. So the car would have traveled 100 meters in that direction, kilometers, right? And the time taken for him to do that would have been, that is from 6 o'clock to 8:30, right? Then, so this is on the first part, then the car traveled in the opposite direction back to A. So therefore the car would have traveled 100 meters again. 100 kilometers. So therefore the total distance traveled by the car is 200 kilometers. Why do I keep saying meters? And the total time now. So this is what we need to figure out here. So the times for which the car was moving would have been stage 1, stage 2, and stage 3. So that's here, here, and here. In stage 1, what is the time we're looking at here? So from 6 to 7 is 1 hour. Right? So let's put our time in hours at the bottom. So that is 1 hour. Then in this interval here, from this point to this point, that would have been 1 hour again. Right? And then we need to look at this piece here, stage 3. Stage 3 is from here to here. So that is 1, 2, 3, 4, 5. Right? So that's 5 15-minute intervals. So that will be, so from here to here is 1 hour, and from here to here is 15 minutes. Right? So that is 1 hour and 15 minutes, right? Which is really represented by 1.25 hours. Right? So this will be 200 over 3.25, and this will give me 61.54 kilometers per hour, right? Now I know this last part would be confusing for some students, right? So you can pause the video and look at the solution again, okay?